Hello everyone, my name is Sanjeev. In this video, I will demo how to set up MuleSoft Runtime Fabric on Amazon EKS Kubernetes cluster. This is the Anypoint Runtime Fabric documentation page provided by MuleSoft. MuleSoft Runtime Fabric architecture is based on the Kubernetes cluster containerized environment architecture, and it deploys the Mule application on Kubernetes cluster. We can use the Kubernetes public cloud offering like Amazon EKS, Google Kubernetes Engine GKE, and Azure AKS and others to create the Kubernetes cluster, and we can install the runtime fabric on these Kubernetes provided by public cloud offerings. We can also use the bare metal public distribution like Amazon EKS Anywhere and all these to install the runtime fabric on bare metal. Here are the benefits of using runtime fabric. It provides isolation. Applications are deployed in separate container. So there is a separate runtime server per application. You can also have the multiple runtime version on the same cluster. So some of the application can be deployed on MuleSoft runtime 3.9 or 4.1, and others can deploy it on 4.6, 4.5, etc. It also provides the scaling of applications across the multiple replicas, so you can scale the applications horizontally. Runtime Fabric also provides the automatic application failover, and you can manage the applications using control plane. So we can deploy the application using runtime manager. We can configure the application at deployment time. Managing and installing the runtime fabric is a shared responsibility. So boxes given in the blue are responsibility of MuleSoft, and boxes that are in the green, those are managed and need to be provided by customers. So runtime fabric use the control plane that is provided by MuleSoft. It also provides the runtime fabric agent, and MuleSoft also provide the MuleSoft runtime. So MuleSoft runtime provided by MuleSoft. Customer need to manage the cluster, so they can use AWS, EKS, GKE, and others to create the Kubernetes cluster. Customer also need to provide the external load balancer, and they need to configure the Ingress controller. They also need to configure the log. They need to configure the logs so they can be sent to the external system like Splunk. They also need to create the applications and API. And for storage, the customer need to manage the storage. And hosting and runtime also need to be provided by customers. Runtime Fabric use the mutual TLS to communicate to the control plane and to communicate to the Kubernetes cluster provided by the customers. So any change in the state of the application sent to the control plane by runtime fabric agent, and runtime fabric also receive the request from the Anypoint platform control plane. For example, to create application, it get the request from control plane, and then it manage all the resources and create the application. So runtime plane sends any change in the application status to the control plane, and it gets the request from the control plane, and it accordingly creates or change the application's configurations. Customer need to provide the storage. For example, storage for persistent gateway need to be managed by customers. So component that provided by MuleSoft, it provides the runtime fabric agent. It also provides the Mule cluster IP service. It helps in discovering peers inside the cluster. It also provides the resource caching. So cluster local cache is provided by resource cache. So these are the core services that are provided by MuleSoft. MuleSoft also provide application services like it provide service for persistent gateway, and also it provides service for anypoint monitoring sidecar for monitoring the and logging. But these services need to be requested by customer, and these are available when customer configure these services for the applications. Here are the list of services that customer need to manage. Like it need to install the Ingress controller, it need to configure the Ingress controller. Any external load balancing also need to provide by customers. Log forwarding to external system need to be configured by customers. Monitoring, network ports, NET gateway and proxies all need to be managed by customers. Host runtime and networking also need to be managed by customers. Customer also need to provision and manage the Kubernetes environment. Like in this demo, I will use the EKS, Amazon EKS service to create the Kubernetes cluster environment, and we will use that Kubernetes cluster environment for runtime fabric deployment. For deploying the application on runtime fabric, we can use the runtime manager. Runtime manager triggers the application deployment. Request is received by runtime fabric agent. Runtime fabric generates the appropriate Kubernetes resource, including deployment, config map, secret, services, and ingress. Then Kubernetes initializes the container and fetches the dependency from the runtime fabric resource cache. Application deployed in the namespace. So whenever we deploy the application, it creates a namespace and it deploys the application in a Kubernetes namespace. So this is the list of the features that are supported by runtime fabric. It supports API gateway, Kubernetes and Docker. Customer need to manage. Installing on Linux distribution supported. Node autoscaling is supported on these environment. External log forwarding need to set up using log4j forward log to external systems. So we need to configure the log4j for sending the logs to the Splunk or ELK. So customer need to provide the Ingress controller setup and configuration. In EKS Kubernetes managed environment, Kube Center is not supported. We have to enable the monitoring and alerting in AWS or respective environment. So for hybrid deployment, we can either use the standalone runtimes, on-prem deployment, or we can use runtime fabric. Using standalone runtime servers, you can deploy multiple applications on the same server. One way it's a good thing because you can deploy multiple applications on the same runtime server, but there is a drawback of it that there is no application isolation. So if you are deploying multiple applications on the same server, and if one application taking too much resources, then it can affect the performance of another application. So that can be improved in the runtime fabric because runtime fabric provides application isolation because it uses its own container, and during deployment time, you can set the resources, how much and what are resources this application requires, and it does not affect the other deployed application because the application does not compete with the other applications. So there is no resource contention is there. And you can also deploy the application on different Mule runtime versions. That's another benefit. Some of the application can have the 4.1, another can deploy it actually in 4.5 also. Now I will move to the demo. To install the runtime fabric RTF on the EKS Kubernetes cluster, we need to install these utilities. So we need a AWS CLI because it helps working with the AWS services. We also need a kubectl so we can work with the Kubernetes cluster. We need a EKS CTL. This simplifies the creation of the EKS cluster. So instead of creating manually, we can use the EKS CTL utility to create the cluster in more simplified manner. We also need to install RTF CTL for installing and configuring RTF runtime fabric. We can also install Helm for installing Ingress Nginx controller. So either we can use the curl to install the Ingress Nginx controller, or we can use the Helm. For installing AWS CLI, we can go to this page, installation page, and we can install from here. So this is the page to install the AWS CLI. Here we can choose the Windows option, and we can run this command to install the AWS CLI. With the help of this command, we can install the AWS CLI. Once the AWS CLI has been installed, we can check the version. I have already installed the AWS CLI, and this is the version that I have installed on my laptop. Once the AWS CLI has been installed, we need to configure the AWS CLI. For configuring the AWS CLI, we need to create the access key. So for that, we need to log into AWS IAM user and password. I have already logged in. Here I need to go to the security credential. And here we can create the access key. So I have already created the access key. I have that already. Once you have a client ID and client secret for access key, you can run this command AWS configuration. In here you can provide the access key. I have already configured it. That's why I'm getting last 4 digits of client ID. But in your case, you can provide the access key ID. Once you provide access key ID, it will ask for the secret access key. You can provide the secret key, and then you can provide the default region. So I'm using default region US East 2, and at the end, you can provide the output format that I have provided JSON. So once this command completes, your AWS CLI will be configured. You can also check this in your users directory. Here under .aws, you can see the two files. One is credential file that will contain the client ID and client secret. In the configuration, you will see the region and output format. Next, we will install the kubectl. For installing the kubectl, we can go to the kubectl installation page. This is the page to set up the kubectl for Windows. We can run this command to install the kubectl. So we can run this command and this will install the kubectl. I have already installed the kubectl. So we can check the kubectl version using this command. So this is the detail about the kubectl client version. Now we need to install the EKS So this is the page to install the EKS and we can click this download, direct download. This will install the zip file and you can unzip it and then put in a directory and provide the path. So let's check the EKS version. So I'm using 0.176.0. Now we can install the RTF So this is the URL to install the RTF utility. We can download RTF utility using this command. So this is the command to download the RTF I have already downloaded the RTF Let me check the version. So this is the version for RTF that I'm using. We can install the Helm from this installation page. And we can click the download your desired version. From here, we can download the Helm. So we can check the Helm version. So this is the version that I am using. This is the latest version. Once we install all these utility that helps in working with the Kubernetes cluster, AWS services, and help in creating EKS cluster, and installing and configuring RTF, and installing the Ingress engine controller. Once these utility has been installed, we can go to the next step to create the EKS Kubernetes cluster. So this is the command that I'm going to use to create the Kubernetes cluster. I will use EKS to create the cluster. This is the command. Here I'm providing the name of the cluster. So we can put the new name here. We can say ABC Mule RTF cluster. So this is the name of the cluster. This is the command create cluster. And this is the version I'm going to use 1.29. Region I'm using US is 2 and node type T2 medium. And I'm using min node 1 and max node 1 because this is a demo. This is not a production environment. So I'm going with more economic installation to show the process. So I'm going to call this command to create the Kubernetes cluster in EKS environment. CLS, and this will create the EKS cluster, EKS Kubernetes cluster. I'm going to hit enter. This is the long process. It will take around 15 minutes to create the Kubernetes cluster. So I will pause the video and I will return back when the cluster is ready. EKS cluster has been created in US East 2 region and it's ready. So we have a cluster now, ABC Mule RTF cluster in AWS EKS environment. We can go to the EKS service. So we have cluster here. The status is active. ABC Mule RTF cluster, that's a name. We can go inside, compute. This is the node group name and this is the node name. We can go to the EC2 service now. And here we can see the instances. So we have one instance T2 medium. We have elastic IP. And EC2 instance is running state. So our ABC Mule RTF cluster has been created 19 minutes ago and it's working fine and it's in a active status. We can also observe the same thing using our kubectl command. So we can get the pod detail. These are the pod created and these are in running state. We can also observe the namespaces. So we have a default namespace. We have a kube node lease, kube public, and kube system. And kube system have the pods. Now I will go to the AnyPoint platform and I will create the runtime fabric and runtime manager UI. I will go to the runtime manager. I will select the dev environment. Here I will go to the runtime fabric, create runtime fabric. I will give the name ABC EKS RTF demo, and on install on options I will choose the AWS EKS. Click next, accept. I will go to the RTF CTL. Now we will validate the cluster. So I will run this command RTF CTL validate, and we will pass this activation data. So this will validate the environment, Kubernetes environment. All validation successful. Proceed with the installation. So now we can install the RTF runtime fabric. We can ignore this error. So we'll proceed with the installing the runtime fabric on this Kubernetes cluster. So for that, I will run this command RTF CTL, and we need to provide the same activation data. This will install the runtime fabric on the EKS Kubernetes cluster. Runtime fabric is ready. Now we can run some kubectl command to know the namespaces. So here you can see that we have a new namespace RTF. So it created the new namespace RTF and installed the RTF on that. We can get the pod detail as well. Get the pods. So we have RTF pods as well for agents and for mule cluster, resource cache, and RTF install job. Now we need to update the license key. So for updating the license key, this is the page that describes and here you can see that in runtime manager, our cluster is in an active state now, and application deployment and log to anypoint monitoring and nodes are in healthy states. To update the license, this page describes the steps. So first need to get the .license file, and then we need to convert in base 64. So either you can use the Unix command to convert the license in base 64, or you can also do on Windows in PowerShell, you can run this command to convert actually the license to the base 64, and then you can run this apply command, RTF CTL apply command, new license. You can apply the base 64 license to the runtime fabric, and later on you can check that new license by using RTF get command. So either you can convert using base 64 minus w0 license file name, this command by opening git bash and then running this apply command, but we can also directly apply license using this command RTF apply new license minus minus file and the name of the file. So I'm going to apply this license, and this is you need to have a subscription. It is not available in trial, so you need to have this license file once you have subscription. I'm going to show you the process. Here I'm applying the file directly using this ---- file command and applying the new license. So license has been updated in RTF. In our runtime manager, right now we have this error: you cannot manage endpoint for apps deployed to the runtime fabric because Ingress has not been configured. So we need to configure Ingress for the managing the endpoints. So first we need to install the Ingress, and then we need to configure the Ingress so we can manage the endpoint when we're deploying the new application. So let's first install the Ingress. So either we can use this command directly, kubectl apply, or we can use this Helm upgrade command. So we'll use the Helm upgrade command to install the Ingress controller, Nginx Ingress controller. So if we have the Ingress, then it will update. If we don't have, then it will create. And we don't have it, so it will install the Nginx Ingress controller. So Nginx Ingress controller does not exist, so installing now. So Nginx Ingress controller has been installed successfully. We can go to the runtime manager, refresh the page. You can see that we still have the error because we installed the Ingress controller, but we still have the error because we have not configured the resource template. So we need to configure the resource template, so when we deploying the application, we can manage the endpoints for the application. So first check the namespace. We should be having new namespace. So now we have namespace for Ingress controller. So we have Kubernetes related namespaces, we have RTF related namespaces, now we have Ingress related namespaces. We can check the ports as well for Nginx. So this is the port where Nginx Ingress controller has been installed. Now, as we said, actually we have error. We cannot configure the endpoint when we deploy the application. So we need to configure the Ingress resource template, and it is required for deploying the application to set the Ingress endpoint for the application. In this template, we can configure annotation, like we can configure the annotation for timeout, we can configure the annotation for rewrite rule, we can provide the Ingress class name, we can configure the rules for the HTTP and HTTPS. So we can get more detail about all this custom Ingress configuration from this URL. So here we can get more detail how this works. The Ingress resource template pulled by runtime manager, and this resource template helps in creating the application endpoint. So we can configure this resource templates. So I have example already. Let me go there. This is the Ingress resource template that I'm going to use it. Here is the kind Ingress. Right now I'm not providing any annotation, but here we can provide a timeout annotation, or we can provide the rewrite rule. You can provide here. So this is the name. This is the namespace that we should provide, and we should have the RTF minus as a prefix for the class name. And this is the host name that I am using, rtf.abc.com. This will be used during deployment time, and this will create the endpoint. So this will be used in creation of endpoint of the application during deployment time. And this is the path type. So let me apply this. So to apply the resource template, I will run this command. Okay, I need to move to the right directory. So this will apply the Ingress resource template. Resource template has been created. We can see the in the runtime fabric. Now we can see that error has gone, and this is the host name that will be used when we create the endpoint, when we deploy the application. So this will form the endpoint of the application. We can get the detail of this resource template by calling this describe ingress command. So this is what we configured. This is the host name. Now we can deploy the application to this runtime fabric. I will go to the application. One more step remaining. Let me go back to the runtime fabric. We have to associate the environment to this runtime fabric. So I'm going to associate this runtime fabric to the ABC company business group, and I will associate this runtime fabric to the dev sandbox environment. Click Save Changes. Now when we deploy the application to the dev environment under this business group, we should be able to find this runtime fabric as a target. Deploy application. We can give the name ABC EKS RTF demo 07, today's date. For deployment target, we can select the RTF, and we have the RTF that we just installed. We can choose the file, upload file. So I have one file here, demo API. Let me select it. Here we can configure the runtime version, Java version. We can set the replica count as much we want. Maximum are 16 replica we can provide. Here we can configure the reserved CPU. So this is the reserved, and here we can provide the CPU limit. So during high traffic, the CPU consumption can be increased by RTF CPU bursting. So this can go to this limit when the needed. You can configure memory. Here you can update the rolling update for zero downtime, recreate, all the replica will be recreated. So all these options you can configure here. We will go with the default. Under Ingress, here we can provide the host. So we can delete and we can add endpoint again. So these are the host available. So we have this host, and right now we don't have any rewrite rule. We will go with the root path / and you can configure property, JVM, parameter, logging. Let's keep everything default and let's deploy the application. Deploy application. So this application will also deployed on a separate namespace. So runtime agent will create a separate namespace and will deploy it there. So we can have some command for the namespace. So it is still in progress. Application has been deployed successfully. Now we can run the Kubernetes command here again. So here we can see the new space. That's where the application has been deployed. So this is the namespace. We can also get the pod detail. So application deployed on this pod. We can check the logs as well. So this is the namespace, and we need to provide the pod name. So this is the pod name -f. So this is the log. Starting mule container, cluster configuration, started app. So this is the app that we provided, the app name is started, and here we are getting deployed. So we can check the log as well. Now to invoke this application, we cannot invoke directly through the browser. We need to get the first service detail for Ingress Engine X controller. So first we need the service detail. So this is external IP of the service of the Ingress Nginx controller load balancer. We need to resolve the IP of this domain name of the Ingress controller from the domain name service. So for that, we need to resolve the IPs first. So in PowerShell, we can run the command resolve DNS name, and we will provide this name. So this will resolve the DNS name. It resolved to these IPs. We will use these IPs to invoke the application. So let me copy this. So we cannot directly use the curl with the endpoint name. We have to pass the resolve option also. So first let me resolve IP address. I need to put here, and then I need to grab this name from here. So this is the name we are using here for application URL. So in fact it is same. So let me copy here. So demo is my endpoint that I have given in application. You need to use the resolve option to resolve this rtf.abc.com, and it need to be resolved to this IP address. So let me invoke this now. So we got the result, message successful. So we are able to invoke the curl command with the resolve option. We need to pass the IP address that is being resolved for this domain name. We can also invoke this application inside the container. So for that, we can run this execute command. So we have a namespace that we found out previously. Okay, we cleared it, so we need to run it again. So we got the namespace here. This is a namespace. Now let me find out the pods for this namespace. So we have pod name, we have a namespace name. Now we can run this command. So let me replace it here. This is a namespace. Let me copy the pod name. We also need the container name. So for that, we will run this one more command. Let me put this namespace here, and let me run this command. This will give the container name detail. Okay, so we have app and app monitoring. Let's try app monitoring. because we got the 2 container. I need to run this command. So I'm running kubectl execute command. I'm providing namespace, I'm providing pod name, I'm providing container name, and then I'm running this bash script command curl, and I'm hitting the localhost 8081/demo. So I'm invoking the application. So we got the response. So we are able to run the application inside the container, and we are also able to run using the resolve option by finding out the IP address for this name using domain name system. So our application is working and running, and our runtime fabric is also in active state. It is associated to this business group and this sandbox environment, and it have the host associated to the Ingress controller, that is rtf.abc.com. This is all in this video. If you like this video, click the like button and please subscribe the channel. Thanks for watching. Thank you very much.